Okay, so let's go ahead and take a peek at this simulation, what you were doing today. So we have a population proportion. So we're saying the true value is going to be the green line, which is 50% or 0.5. And then we've set our level of confidence that was given, and then we have a sample size. And so question one asks us to obviously set all that up, but then did the first confidence interval capture the true proportion? And this is kind of random for all of you. So in mine, this one, it did. So basically, this was my point estimate, and this is what I added and subtracted each way. So this is my possible range of numbers. And so since my green line goes through that range, that one would capture the true value. So I can kind of repeat that and see that there are a few more intervals I can construct because I have my point estimate, and I add and subtract a little bit, and that will kind of shift my interval around slightly, but it's still kind of capturing the true thing. So if I repeat it 10 times, you'll have a sketch here, and everyone's might look a little bit different. But this would be mine. So I've got basically all my intervals are capturing. So percent hit is 100% of my intervals are capturing the true value. So they're all going, the green line's going through all of those. So now if I repeat that, maybe you had one miss, your answers here will vary a little bit, just because again, we're all kind of, this is random samples, so it's going to differ. But then when we do 100 confidence intervals, so if I reset and I do 100 of these, so I hit the sample 25 4 times, I can see now that my percent hit has changed a bit. So if I look through all of these, there's quite a few in here. I'm going to see some red ones come up, and you should have also seen that. So I can even do another sample of 25, and I'll still get a red here and there. So altogether, it's saying there's about 94% of my intervals have captured the true value, or the green line has gone through them. So this red one here, the green line's not going through that. So this interval was shifted down a little too far and didn't capture the true amount. So if we notice some different patterns here, when you take more samples, how many samples of 100 captured? But we all should be pretty close to 94%, because in the long run, the more we sample things, the better estimate we're going to have. So that's pretty darn close to our confidence level of 95. So that's just something to note. Now for number 4, some things maybe you noticed as we're going to drag around the confidence level. So if I drag this around from 95 to 99, I'm going to see some changes in my intervals here. And you should hopefully notice that the intervals get wider. So if we think about that, like you're 99% confident about something, pretty darn confident. But that also means like your interval is pretty wide. So the trend we should notice here is that our intervals get wider, and more of them do capture the true value, because obviously you're making your net wider, so you're going to catch more fish. It's kind of how you think about it. So percent hit here has gone up to 99, which again matches our confidence level, which is kind of interesting. So a pattern to notice is that you increase the confidence level, you're basically increasing how much you're adding or subtracting to each side. So like your interval gets wider. So you've captured more numbers. So you can say, yeah, I feel more confident because there's more possibilities in my numbers, but also you've got like a really wide range. So not always the best thing. So let's reset. If you were doing a similar pattern, if you do another 100 samples, if we lower the confidence interval down to 80, so pretty low here, and I do another 100 samples, I'm going to see really skinny intervals. And I've already see like 4 here that don't make it to the green line, because again, it's a lot shorter range at this confidence level. So I don't feel as confident, because again, and because my range of numbers is kind of short. So I can do this one over and over, and eventually we'll notice this is kind of close to 80. And so again, it matches that level of confidence. So if we wanted to generalize kind of an interpretation of what we've done, this would be a great way to think about it. Basically, your confidence level is how many of your intervals are capturing the true value. So the more confident you are, the more of your intervals are capturing it. But again, your interval also gets a lot wider. The less confident you are, the interval gets a little skinnier and not quite as many captures. So here's kind of the wording. If we take many, many samples and calculate a confidence interval for each, we expect about 80% of them to capture the true proportion, population proportion. Similarly, if I was doing the 95 and the 90%, or 99%, I would just replace the 80% here with those confidence levels. So now if we adjust the sample size, you should have noticed one other pattern. So the more we sample, if I just up the sample size to 100, sorry, 250, what are we doing? And hit sample, I got some pretty tiny intervals, but also a lot of my intervals, like my point estimates, are pretty darn close to that green line, which is nice. So the interval's a lot narrower, but the variability in my samples I'm getting, those black dots, is a little bit less. Because again, if I sample a lot of people, I'm getting a really good snapshot of the true thing. So here I've got a lot of my black dots aligning pretty well to that green line, like they're getting pretty close, and my interval is it's a pretty tight gap. So why does that happen? Because your sample size and your margin of error are actually kind of related. There's a formula for margin of error we'll eventually get into, but as your sample size goes up, your variability is going down. So like your margin of error or margin of variability is getting a little bit less each way because you're getting a better picture of that true population, the larger sample size. So let's summarize. These are our important ideas. So to interpret a confidence level, this is the statement. So just like we had a statement for interpreting the confidence interval, there is also one for level. So it is linked to the idea that in many, many intervals, this percentage of them is going to capture the true amount. And then here are kind of our patterns that we want to make sure we notice from the simulation. So the confidence level goes up, wider interval, and your margin of error then has to be wider because that's what you're adding and subtracting. So you're making a wider thing. So you feel more confident, but like, again, you've got a really wide range. So like, yeah, it's like the numbers are between here and here, and it's like all possible numbers. You're going to feel really good about that. But probably not the most accurate. So the other trick is to up the sample size. That's always gonna like narrow your interval, but generally will give you like your point estimates are gonna be more on point each time. So even though the interval is narrower, it might not catch the true value. Your point estimates are gonna be pretty much on par with the true value regardless. So that's pretty good. So the last thing is that margin of error does account for sampling variability. So that basically means like your margin of error is the number you're adding and subtracting. So like if your point estimates are super variable and all over the place, that's going to be not great. But your margin of error is that constant number you're adding and subtracting to make the interval. So it's going to account for, basically the little bit of shifting in your black dots, like it's kind of caught by your margin of error either way. Now, that's if you're sampling randomly. So if you don't sample randomly or you have a biased way of sampling, your results are just going to be screwed up. Your point estimates are going to be shifted way to the left or way to the right, and your margin of error is not going to correct for that. So like your black lines here, off of each of these points, wouldn't catch potentially the true thing. You might have a lot of your point estimates here or up here if you're doing biased sampling.